Okay, we're given the graph of an original function and want to know when we're going to have positive derivatives on which intervals and negative derivatives on which intervals. So this basically goes down to when is the function increasing and when is it decreasing. We may have heard this same question asked in that other way in the past. So on the left-hand side, the function is increasing initially. So it's going to have positive derivatives whenever the function is increasing. We'll go ahead and say, even though we don't have an arrow going off forever, because it went off of the graph paper, we'll assume it keeps going that way forever. So that would go from negative infinity for an x value. And it looks like it stops at the top here where our derivative would be 0, a horizontal tangent. So that's from negative infinity to negative 1. In these cases, we always leave off the endpoints. All right, so it's negative 1, but we don't include that with either the positive or the negative derivative intervals. All right, between negative 1, after the negative 1, I should say, it starts decreasing. So that tells us that our derivative is going to be negative, all right, because our tangent lines are going to be negative slopes for this interval. So that started at negative 1, again, open interval, and it looks like it ends at the bottom whenever we have a value here where we're going to have a horizontal tangent line or the derivative would equal 0. By my best estimation, it looks like that's about 2.5. Again, leave it an open bracket. From there, we start increasing again, telling us that our derivative is going to be positive. So that goes from 2.5, continues on forever to the right, so to infinity. We'll toss a union symbol in between there. And that's how we can answer this question. Just be careful, it's always open intervals as we take a look at these. Increasing corresponds with positive derivatives. Decreasing corresponds with negative derivatives.